All right, today we're going to crack a really fantastic logic puzzle. It's a mystery that's all about the special properties of prime numbers. And trust me, it has a beautifully elegant solution.
So here's the heart of the challenge. We've got three prime numbers, let's call them P, Q, and R, and they all have to be less than 20. They're all connected by one single simple rule. Our job is to figure out, based on that rule, how many different unique sums we can get when we add them all together.
And here's our game plan for how we're going to solve this thing. First, we'll meet our cast of prime numbers. Then, we'll decode that crucial clue that links them together. That's going to lead us to a huge shortcut, a breakthrough, which will let us hunt down every possible sum and then, finally, count up our final answer.
Okay, let's get into it. Section 1, a prime number puzzle. Time to assemble our cast of characters.
So, just a super quick refresher on what a prime number is. It's any number that can only be divided by 1 and itself. Like 2, 3, 5, 7, and so on. They're kind of like the atoms of the number world, the basic building blocks, which is what makes them so cool.
And here they are. This is the complete set we're allowed to work with. The three numbers we're looking for are P, Q, and R have to be chosen from this specific list of 8 primes. No others allowed.
On to Section 2. Unlocking the clue. We've got our numbers, now we need to figure out the rule that connects them. Honestly, this is the key to solving the entire puzzle.
And here it is, P minus Q is equal to Q minus R. Now, it looks pretty simple, right? But this one little sentence tells us absolutely everything we need to know about how these three primes are related. So what is it really saying?
Well, what it means is that our three prime numbers are in what's called an arithmetic progression. In plain English, that just means they're all perfectly, evenly spaced out on the number line. The jump from the first number to the second is the exact same size as the jump from the second to the third.
You can think of it like this. If Q is our number in the middle, then P is just Q plus some difference, we'll call it D, and R is just Q minus that very same difference. This perfectly balanced structure is about to become very important.
Okay, Section 3. Now this is where things get really interesting. We're about to uncover a secret shortcut, the breakthrough that changes the whole game, and it all comes from what happens when we look back at the original question.
Remember, the whole point of this is to find the sum P plus Q plus R. So, now that we know about this balanced structure, is there any way we can simplify this expression?
Let's walk through it together. We start with P plus Q plus R. Now we just swap in those new terms we found for P and R. And watch this. The plus D and the minus D completely cancel each other out. Poof, they're just gone. And what are we left with? Just this beautiful, simple result. The sum is always just 3 times the middle number, Q. This is the breakthrough. It's huge. We don't have to guess random combinations of 3 numbers anymore. All we have to do is test which of our primes can successfully be a middle number.
So let's move on to Section 4, hunting for the sums. Our discovery completely changes our strategy. Instead of random guessing, we can now just go through our list of primes one by one and systematically test if they can work as a valid middle number, as Q.
Okay, let's start the hunt. What if our middle number Q is 5? Well, let's try a difference of 2. That gives us the triple 3, 5, and 7. Are they all primes from our list? Yes. So our first valid sum is 3 times 5, which is 15. 1 down. Okay, what about 7? If we use a difference of 4, we get 3, 7, 11. All primes? You bet. The sum is 21. Now, 11 is where it gets interesting because it actually works twice. A difference of 6 gives us 5, 11, 17, and a difference of 8 gives us 3, 11, 19. But notice this, and this is a key detail, even with 2 different triples, the sum is the same, 33. Finally, let's try 13. A difference of 6 gives us 7, 13, 19 for a sum of 39. And what about the other primes, like 2, 3, 17, and 19? Well, you can try, but you'll find they just can't form a valid prime triple from our list, so they're out.
We found them all. We've got all the pieces we need. Now we just have to answer the original question. But there is one little hidden trap we have to be really careful to avoid.
So let's just list out every unique sum we found during our hunt. We got the value 15, we got 21, we got 33, and we got 39. These are all the possible distinct values for our sum.
And right here, this is that hidden trap I was talking about. It would be so easy to just count up the number of triples we found. There were 5 of them in total. But the puzzle very specifically asks for the number of distinct sums.
And because both of those triples with 11 in the middle gave us the exact same sum of 33, we only get to count that result one time.
So the final answer, the number of distinct possible values for our sum, is 4.
And that's how you solve it. It really makes you wonder, doesn't it? How many other complex problems out there are just hiding a simple secret, just waiting for us to find that one elegant shortcut that makes everything click into place. Thanks for digging into this with me.